physically download everything.
All right. So let's get on started. So today's class is our last class before the midterm. So we will try to get to a few kind of guidelines. I do have a little bit of a review for some extra problems to review for that midterm. So we have a couple of sections left to go, 4.5 and 4.6. I'll try to do a little bit of a review of kind of the previous sections in chapter 4 as we go here as well. And then at the end of class, I will talk through, some of you guys got a invite to a proctored midterm meeting. And so I'll talk about, for those who got that email, what we'll want to be doing this Thursday, because that's going to be our midterm. So we'll start with section 4.5. We'll take a look at a problem, and then we'll kind of intersperse a little bit of a review through the live assignment. So we have one live assignment 5 that's on today's date, and so we'll jump into that in a little bit as we go through class. So 4.5 really just looked at graphs that have vertical shifts and altitude or amplitude changes. So really a change in the midline and a change in the amplitude. So we'll go through one of these and we'll kind of go back to the previous section where we have maybe a little bit more complex graphing situations, and we'll kind of walk through the thought process with those again. So if I considered graphing this one over the interval 0 to 4 pi, let's just go through kind of our checklist. And this is a helpful thing, hopefully, for you guys as well to do on your own when you're doing problems, is to think about these qualities, the amplitude, what vertical shifts we might have, what midline we might have. What do we see as our amplitude for this problem? Yep, 2 would be the amplitude. That's the A value right in front. So since A is equal to 2, our amplitude is absolute value of A, which is also 2. So that works. So that means our height on our sine curve is going to be 2. And then what about our vertical shift? Right. So if we're at -3 for the vertical shift, that would be kind of our D value in the equation. Our vertical shift alters our midline, so those are kind of one and the same. So vertical shift we can think is down 3 units, and so our midline we would say is y is equal to -3. So when we go to graph this, I first want to think about finding my midline, and then I'm going to graph my function off of my midline. So since my midline is -3, I'm just going to draw that in on my graph. So let's do it with a different color. We'll do my midline in blue at -3, a little dotted line. So there's where my graph is going to be centered at. I don't have any other shifts left to right, and so I'm just going to want to draw a sine curve. So if I worked with a sine function, that's the last thing I want to consider. Does the sine function start at the amplitude or the midline?
I think it starts at, I forgot whether it's
Midline.
Midline, right, because regular sine function starts at 0, right? So if we didn't have any shifts, it starts either at...
Cosine starts at the, what's it called? The amplitude?
Yeah, cosine would start at the amplitude, or 1.
Okay, I was getting them
depending
mixed up.
on what that amplitude is. So either sine is either going to start at 0 or just at the midline. So if there is a vertical shift like this, it's just going to start at that midline, the new starting point. All right, and the other thing we know is it's got an amplitude of 2, so we're going to want to draw that in as we go as well. So let's take a look at that. So we're starting at the midline, so that would be starting at 0, -3. And I do have an amplitude of 2, so I'm going to be going up 2 units. And again, notice that the 2 pi is broken up into, really, we can consider 4 little sections there. So we'll go up on one section, back down on the second section, hit our minimum by that third section, and then back up to by 2 pi. So there is our, oops, I did that just a little bit too high. Let me redraw that one. This one should be up at only 2 units. There we go. That looks better. Just an amplitude of 2. There we go. That looks much better. So I have a maximum at -1, it looks like, and a minimum at -5. If I wanted to continue that graph, we're just going to take that same pattern and graph it over the 2 pi to 4 pi range. So we could consider continuing that pattern up, down, back to the midline. And that would be our graph over the 0 to 4 pi range. So we make 2 cycles of sine over that 0 to 4 pi range. All right. Any questions from this graph with the components playing on that?
How do you figure out what cycle is what? I tried watching your videos and I get the general idea, but it's still kind of vague for me.
Yeah, so in terms of like where, like just the shape of the sine curve, is that?
No, more like how do you figure out when you have like a full cycle, like which one's a full cycle and how many cycles
Sure.
are in a thing? Because like
Yeah,
you split it
so
up into 2, and it's just like originally I would have thought it was 1, and I
well,
so
yeah,
it's
so
just like,
it is, yeah, so since this has, notice that this equation here, it had the b value of just 1, because there's no number in front of the x. So that means that we're going to do 1 cycle in 2 parts. That's our regular period length for the sine function. So if we just boil it down to this section right here, which is usually what we'll do, is just boil it down to a 0 to 2 pi section. Red is our just 1 cycle of sine. So when you're actually going to graph it on the computer, that's really what you're looking for, is this first cycle. I'm just showing you that in purple, that cycle just continues that same pattern.
okay. It was just like there's some of them where it's just like there's like more than one cycle on some of the other ones, and I was like, I don't
Right.
know.
Yeah,
And
and so that's
I was
based
having
on
trouble
the
finding
b
that
value
out.
again. That is
Okay.
based on the b value. So if you have a 2 in the b value, that means you're going to go through 2 cycles within 2 pi.
Yeah,
But we don't
I had
have
some,
that.
yeah, I had some like slight trouble in like for creating my own equations with the graphs. I'm like, wait a
Right.
second.
Let's look back at the previous section, and we'll do a live problem that pertains to that section and try to do a sketch, because those ones are a little bit more complex. So if you guys want to join me in live assignment 5. We'll go to that now. And we'll just hit, and this will get at your question of kind of the shape of the graph in terms of getting to multiple cycles of a sine or cosine function. So I'll open this up for you guys, and I'm just gonna do this on the blackboard. It'll be easier to write out for you guys. So in this question, we want to graph the function y is equal to -3 sine 3x. So notice that we have a number in front of that x component. And so we do have a change in the period of our graph, or the number of cycles between 0 and 2 pi. So I'll give you guys maybe a few minutes here to jot down what you think the shape of that graph would look like. And you're welcome to put that on the graph itself. And I'll just go to the blackboard and write this out so we can do a sketch.
It just kicked us out.
Oh, sorry. I don't know why it's doing that now. Usually it, no. Give you guys some time doing that. All right, I'm gonna try to do this on my second device so it doesn't knock you guys off. But if it does, we'll just walk through the problem and then I can open it back up. So let's take a look at this one together. Of the process of graphing. So if we take a look at the original equation here, what would be our amplitude?
3.
Okay, 3, right? So A and B, so A and 3. The absolute value is going to be 3. So we do say the amplitude is always positive. So we'll put those markers down. Get 3 and 3. All right, and then what is the other 3 representing here? What does that affect?
That's the period of 2 pi over 3.
Right, exactly. So that B value of period, 2 pi, E is just 2 pi over 3. Excellent. 2 pi over 3 is our period, meaning that we're going to do 1 cycle every 2 pi over 3. So 1 cycle in that range. Okay, excellent. So if I'm going to do 1 cycle in 2 pi over 3, so let's just mark that off. This is say 2 pi. That would mean I'm going to be doing another cycle of sine after another 2 pi over 3, or we could call that 4 pi over 3. We'll have another cycle, and then the next cycle would come at 6 pi over 3. If we're adding 2 pi over 3. So we'll have a full cycle of sine in each of those windows there. Remember that this here is related to, so this is saying that we're going to have 3 cycles sine and so that's an equivalent statement, either 3 cycles of sine in 2 pi or 1 cycle in 2 pi over 3. So since we're going to be graphing this on the computer, I won't take a whole lot of time, but I will give kind of our shape here. Remember that our sine function here starts at our midline. In this case, the midline has to be 0. We haven't moved that midline. So when I go to graph this, we always start at the midline. Since this is a negative sign, though, it's a negative, I would start at our midline. Then I'd be going down to -3 first, because it's going to be a decreasing function to start, because we have a -3 there. We'll be back at the midline, and then come back by the time we hit 2 pi over 3. And so we'll do this really like 3 times, and we'll have a sine function that looks like this in 3 places before we get to a magic 2 pi. So we continue.
And that's how we would graph it?
Yeah, yeah. So I would consider, we want really 3 cycles between 0 and 3 pi is the idea. So let me keep drawing this out, and then we'll go back to the graph. So have something like this again. We're doing our sine curve. Do this again. Third time. So we kind of see the goes down first and then does our 3 sine waves, and then we're back at our starting point at 2 pi. So that's the idea here.
Could we somehow verify this on our what's it called, calculators? Can you hear me?
Yeah, I'm going to the graph right now. Is that your question?
Yeah, I was wondering how can we like verify it on a calculator, on the TI-84 graphing calculator?
You can't. You can, but I mean, before you put it into this, you mean?
Yeah.
I guess there's a way to do that. That's not really the intention, though. I guess the intention is just to be able to sketch it out.
Okay.
But so let's take a look. I want to do 3 cycles of this sine function. So notice I'm going to be using this the graph that's when you see the draw on the bottom of the graph, the right one is going to do your sine function much better because it's got a midline point and a amplitude point. So that one I'm going to use here. I'm starting at my first point at the origin, and then have a second point, just draw anywhere, and then you can work the shape. So here I want to be able to do 3 cycles before 0 and 2 pi. So let's see, that would be 1, and that would be 2. So that's only 2 cycles. I need to bring it a little bit closer. So let's see, we have 1, 2, and 3. I think that graph will do it right there. So notice that it's kind of a lot of lines in close succession, but if we follow it with our pencil, we should have 3 full cycles between that 0 and the 2 pi. This should have our, oops. Again, let me clear.
If a mistake like that happens where we accidentally added that, like how you just did right there, would you take points off for it if you can tell, you know,
well,
what we were trying to...
if you, I mean, it's pretty obvious when you add 2 graphs, just do a clear all and do the graph again like I'm doing. But yeah, I mean, if there's it might not even, I don't know if you draw 2 graphs, it might just give you an error and then have you do the graph again. I'm not sure exactly what the...
No, like if we accidentally, like right before we push the submission button, we accidentally like pressed like the graph and it gave us another line and it accidentally like added to it.
Yeah, I mean, I'll be looking at these but each problem. So yeah, if something like that happens, it's obvious that it was just a glitch. I can definitely look at that.
Perfect.
So let's see. That would be 1, 2, 3. There we go. I think that's the correct. So that's what I'm going to be looking for. Again, amplitude we could say is 3. The period was going to be 2 pi over 3. So
the idea of a period is that it's always 2 pi over that number, right?
Yeah, it would be. Yeah. So the 2
right,
pi over b is always going to be the period. 2 pi over b.
Perfect.
All right. Is there any other questions for this specific problem? Everybody feeling okay with the amplitude and then the period change?
No. I wish we did this before we had those assignments last time.
I agree because the graph just totally messed me up. I wasn't able to get it in the homework at all, so I got like a 40.
Okay.
I kept on going over it like 5 times until I got it. Because it was like, because I was having trouble with the figuring out the period mostly, which now looking back on it, it seems really dumb.
I had to hire a tutor.
And the graphing part is just like, okay, I have a general idea of what I'm supposed to do, but I don't know how to draw it.
Mm-hmm.
Did you say last class we could use Desmos, or did I just get that from nowhere?
You won't be able to use Desmos on the midterm exam, but you
Okay.
can use your TI calculator.
Okay.
Yeah. All right. Section. I don't know why it keeps throwing me off, but it's okay.
What did you say?
Alright.
Sorry. Whenever you move
Oh.
stuff or like zoom in and zoom out, you literally glitch like crazy. And you're not the first teacher to have that. So it's just like, what did you say? I didn't catch anything.
Oh, I was just saying something to myself. I wasn't sure why the program was closing every time I opened it. Nothing for you guys though. So let's take a look maybe at another one of these with a negative amplitude, just to practice these ones again. So for this cosine function number 2, what would be our amplitude again?
4.
Okay, the 4 is the amplitude, so the A value specifically is -4.
When it's sin, it's always positive, right?
It's no, not always. Negative or positive. So like this is a negative sine graph.
Okay.
So we could have a positive or negative on either cosine or sine.
The
Gotcha.
amplitude makes it absolute. That's why it's always positive, though.
So the amplitude itself is always positive, yes.
Gotcha.
So the amplitude is always the absolute value, B4. It is a distinction, though, we want to make that the original A value is negative, so that will affect the graph in terms of its direction. So there's our A value. The D value, again, here is just what we add or subtract. And so that would be our vertical shift. So this would say we're going to be going up 2 units, or y is equal to 2 is that new midline. So we can go and draw that midline first. That's at +2. Now, if we have
homework, it doesn't ask us for the midline, does it?
It probably just has the vertical shift, but
Yeah,
the
just
vertical
ask for
shift
vertical.
is...
Yeah, just the amplitude and the vertical shift.
That's fine. I mean, the vertical shift is the midline, so that's why I kind of did it this way to just show you guys that the midline is the same thing
Gotcha.
as the shift, but it helps you graph it, really, if you know the midline.
Oh, okay.
It's just a more helpful way to say where to start. So the cosine function, where does that start?
Oh, that starts right on the. I think the midline, right when on the midline or at the amplitude.
No, it starts at the amplitude.
Amplitude, right?
And
So
it's
it
gonna
usually
be
starts. Yep, it will usually start at 0, 1, or we could think about the amplitude. So in this case, the amplitude is -4, or really 4, but we do have a negative number there. So in this case, we would start it at that -4, because if we put in x is equal to 0 here, that would say that this is -4 times cosine of 0 plus 2. Cosine of 0 is always 1. And so this would end up being -4 times 1 plus 2, or we'd start at -2.
Well, Professor, the way I remember it is I just start wherever it has cosine, I just start wherever the amplitude is, like -4. That's how I remember it.
Right.
Is that
Yeah,
a good way of
so
remembering it?
yeah, so we would start at the -4, but we do have the shift of the 2 units. So we just want to be careful of shifting that. It's 4 units down from our midline. So in our case, 4 units down from our would be -2. So here our graph is going to go from -2 to 6, which happens to be 4 units above the midline. So our cosine starts at the -2 in this graph, and then we'll do our cosine shape, so dividing that into fourths from 0 to 2 pi. We'll have our cosine shape back at the midline, maximum, midline, and down at the -2 at 2 pi. So that will be our full cycle of cosine on that 0 to 2 pi. And if we wanted to graph that again, we don't necessarily have to graph like 2 graphs necessarily when we do it on the program, but we can just note that this is going to have the same pattern over the 2 pi to 4 pi range. So we could put this as the same cosine graph. Yeah.
I wanted to ask, why is the peak at 5? I mean, on the first
Oops,
cycle.
did I? Oh, I did that again. I just go to the wrong one. So let me get that up to 6. That should be at 6.
I mean, either way, why is it at 6? That's what I don't know.
Yeah, so that would be, so notice that's 4 units away from midline. So we're going 4 units to our maximum, and then this would be 4 units to our minimum. So that's the amplitude.
The thing is, your amplitude is 4, so wouldn't the highest view go is 4, +4, -4, and that's it?
Because we've done a shift of 2 units,
so you would add to
the maximum would be 6 now.
Yes, sir.
Yeah. So it should be at 6 when we make that adjustment. There we go. So there we'll have our 2 rotations there. But really, when we go to graph, you're really only concerned with the cycle between 0 and 2 pi.
Mr. Coleman?
Yes.
My other question is how I've struggled with this too. How would you know where to put those little points on the graphs? I mean, you kind of did it. You did two spots to the left. So how did you know where to put the points on the?
Yeah.
Side?
So when we have a normal period of 2 pi, the sine and cosine function are always kind of divided into kind of 4 sections. So like this section, and then we got that, and then the section here, and then the section there. And each of those sections have to be 1/4 of 2 pi. And so those grid marks there would happen to be pi halves, pi units, and 3 pi halves units. So if we need to do a sine over 2 pi or cosine over 2 pi, we're always going to have like 3 points in between that are equal distance.
Makes sense.
Yeah. So it's more of a pattern thing. Once you do a lot of cosines and sines, it's going to have that same pattern. All right, I'm going to try to from my other computer so it doesn't shut you down. Let me close that. And hopefully bring you guys up for the next one here. So it open up and I'll give you guys this is just a graph of a cosine function, and we want to find its equation. So I'll give you a minute to look at live problem number 2. And just a strategy to maybe think through these a little bit more would be kind of thinking about how you would graph in reverse. So if you consider, again, thinking about where the midline is, what the amplitude is, and then consider the period and if we have a shift or not. So there's a lot of things to consider here, but we want to check off kind of each of those qualities one by one. It makes it helpful. Put those things together. Yeah, depending on what function is the base, the period does, or the phase shift is a little tough. So we'll talk through that for this one. All right, so let's just start discussing this. We've had a minute to look at it now. Let's start with our midline. Where do we see our midline for this graph? That would be kind of the D value that we add or subtract. Okay. Yep, the midline would be 2. So in the other words, the D value in our equation should be a +2 at the end of our function. That's right. So that takes care of that. What do we see as the amplitude for this cosine function? What will be our amplitude? Okay, there's a 4 on the amplitude. That would be right. So we do have an amplitude of 4, so that would be 4 cosine x plus 2 at this point. So let me maybe write these in as we go.
Well, Mr. Cogman, why is it 4 on the amplitude? I don't understand.
Amplitude? Yeah, so let's look. So if I looked at the midline is 2, because we go kind of the average between 6 and -2 is 2. So the midline is at 2. And then from 2 to my maximum is a range of 4 values. So if I started at 2 and went up to 6, that would be 4 units, or 2 down to -2 would also be 4 units.
Yes, sir, I got it now.
Cool.
Yeah, I tend to
So-
just count from the bottom to the top and see if there's an even split, and we're like, okay, that's the midline.
Yep, that's exactly right. Yeah. So just look at the maximum, minimum, take the average, right in the middle should be your midline. That's exactly right. Okay, so I've got the midline at 2, the amplitude at 4. We have a cosine function. So if I have a cosine, let's just start now with where kind of our starting point for the graph would be. If I have a cosine function, that means I need to start at my amplitude. So if I start at my amplitude, that means I'm starting at kind of that first peak, and I can't really pin the program. The peak I'll zoom in is right here. Okay, so I would be starting at that amplitude of 6, and that happens here, 1 box before pi over 2. And so we need to figure out maybe what that is, because that's going to be really what my horizontal or phase shift is going to be. We'll take a look at that next. If we looked at the period for this graph, what is the period anyone find? The 3 pi over 4?
That was the box before the pi 2. It was a guess. Like, I don't
Okay.
know.
Well, yeah. So let's consider this. If we looked at the 2 peaks on our graph, the 2 maximum points, one is coming before pi over 2, just before pi over 2, and the other one is coming just before 3 pi over 2. So what's the distance between those 2 peak points? I think
3?
if you took, what's that?
Is it 3?
Not 3. In terms of boxes, like boxes, it would be 8 boxes, which represents pi units, right? It would be pi units that it's going over. So the period here is going to be pi units. If you counted the boxes between those 2 peak points, it is 8. And so that would represent in this graph pi units. So the period would be pi here. All right. Is everybody okay with the period being pi units on this one?
So it's y equals 4 cosine x plus 4. And then what's after that?
So we'll draw this out. I'll get all the info on the blackboard, and then we'll write out the equation.
Okay.
I'm just wanting to walk through it with the graph, and then we'll jot them all down again.
Okay.
Okay. So let's go to the blackboard and so the graph we have. I'll just draw this first cycle. We had our midline at 2. -2, 6. Our graph looked a little bit where we reached our peak a little bit before. Okay, so we ended up reaching our maximum here just a little bit, one box before pi over 2. And so this is what I want to talk about here on this graph. We considered kind of the 4 boxes or the 4 tick marks before pi over 2. This is 0. Halfway in between would be pi over 4. And then the in between this, we had pi over 4. This is really going to be pi over. Oops. Anyone do that? Me. This would end up being pi, and this would be 8. If we looked at kind of fractions in between these, pi over 8, 2 pi over 8, pi over 8, and pi over 8 would be those fractions. And this is what I want to consider is our I've over here. So this is going to be our phase shift, which is that 3 pi over 8 for this graph. Again, that's kind of one little box left of the 2 pi, or the pi over 2.
So, Professor, to find the phase shift, you want to find the first peak or trough, I guess, and then that's just essentially.
Yeah, so in this case, we'd be finding the first cosine function. So the cosine starts at that amplitude. So if this was a sine function, I would go and start with, the first place that we hit the midline. So I know cosine functions start at the amplitude, so that's where I'm going to think about kind of where my starting point is.
Got it. That makes sense.
Yeah. So we've moved 3 pi 8 in the right direction, so that's our phase shift. So I think we can try to put this together. We had our amplitude, our b value, or at least our period was pi units. So if our period was pi units, that would mean that our b value was 2, because we could do 2 cycles in 2 pi. And then our shift that we made was 3 pi over 8. So that would be kind of our value, 3 pi over 8, or the C over P. So let's consider how to make that the that is 2. So let me get all that where it needs to be. So this was our 3 pi over 8 for the shift. Okay, so if we put all together, this is what I think we'll have. So y is equal to, my first item is my amplitude. That was the 4. We have a cosine base, cosine. And then in my parentheses, is where we want to be really careful. We have a b value of 2 since my period is pi. So that would do another parenthesis here, and we've just shift of 3 pi 8 units to the right. So that means that we're going to be subtracting that from my variables. So that would be pi 8, and we'll have kind of that double parenthesis inside. So there's my shift, my 2 for my
doesn't
period.
like that form.
With that,
the assignments, they don't like that form. They want it 2x.
okay, we'll
minus.
change it, but we'll change it to its desired form. But for right now, we'd like to write it like this, so we can connect it to the phase shift. So we certainly can reform it afterwards. What's the last thing I need to add to this?
The +2.
Yep, +2, because I do have a midline. So I need to just add 2 on the outside.
I have a question. Was the amplitude not a negative?
In this case, it would not be negative because we considered the starting portion at the +6.
Okay, thank you.
Yeah, so since we did start at the +6, we can consider it as a plus.
I have a question to clarify that. You literally are going in the middle of -2 and 6, right? To find 2.
Yeah.
Okay.
We're taking the average line, if that's your question. Yes.
Yeah. Thank you. Sorry.
Yep. That's exactly right. So the midline is always going to be the average of your maximum and minimum. If you needed to rewrite this in a different, then you gotta just distribute your 2 to then minus x was like 4 2.
Professor, why is our C over B value negative and not positive in this?
Your C over B, so the C over B is always kind of in the equation itself, it's always kind of opposite of the direction you go, because it's kind of, it's kind of the overcompensation for your shift. So if you considered I over B positive, we're at, if we input that into the equation, that would be kind of a cosine of 0. When we put that into the equation, that would make it a 0 in the cosine function, which is mimicking where I would have a starting point.
One of my teachers helped me with remembering a lot of stuff when it comes to these equations. Most of the answers, if they're in parentheses, they're the opposite of the they go in the opposite direction, so they're lying. So if it's a negative, it's going to be on the positive side of the graph, while if it's a positive, it's going to be on the negative side of the graph. That's how I remembered it.
Yeah. So it's really just compensating the other direction so that our starting point can be shifted in that direction. Okay.
Does it matter if I put into the live assignment? Because it keeps deleting every time I put it in.
Oh, really?
Yeah, I put it in like 4 times.
No, it's okay if you don't have it. I don't know why it should be open there on the.
Okay. Oh no. what's going on, but it's fine.
Okay. It's okay. It's not gonna count. This one doesn't count for points, so you're not losing any points on it.
Okay, good.
Okay. Is there questions I can answer for kind of the pre-graphed equations? Go with maybe one more assignment ones with the negative sign function, just to recall what this is going to look like. So one thing to remember is if we have kind of the singular number out in front, that doesn't make, it could either be on the front or the back half of the equation. It doesn't matter necessarily that it's in the front or the back. So this is really a +1 for our midline. So that's our D value. We have another A value there. So a couple things to consider: if our A is equal to -3, our amplitude would be still +3. And then our vertical shift would still be +1. So a few mistakes have been made in past classes with calling that a -1. So the negative still just applies to the 3. The 1 itself is still positive. So we're still going up 1 unit, or have a y is equal to 1 for that midline. So if we shift 1 unit up, again, that midline is at y equals 1. All right, and now here's the question. Where do we start this graph? Okay, 1 vote for -3. Okay, change the vote to 0. Okay, yeah. So here the sine function does start at the midline. And so we will want to start at the midline when we go to 0. So this would end being, since we're shifted 1 unit up, we'd want to shift our starting point just 1 unit up. So it would be normally at 0, but we're just going up 1 unit. Okay, now if I consider the 0 to 2 pi range, again, I'm going to kind of cut this into fourths. There's going to be a point at each of those 3 markers somewhere, and then we'll get back to my starting point by 2 pi. Where should my first point go at that first marker? I have a -3 in front of my sign. Amplitude from here is 3. So if I go 3 units up, that would be at 4. That would be where my maximum is going to be. Where would my minimum fall?
-2.
Yep, -2 would be my minimum. So I'm going to be -2 to 4 is my range. All right. Notice that these points are really pi halves, pi units, and 3 pi halves. Those are the positions on the graph. So at pi halves, where's a marker for this one? I have a negative cosine graph. That means we're going to be starting as a decreasing function. Right, that would be right, Anya. So I'd start and I go for my minimum first. So that would be, in this case, -2. And then we'll be back to the mid, and then we'll go to our last. So oops, and I did that wrong again. Let me back it up. Maximum, there we go, 3 units, 3 there. So there's our full graph right there. So we can think either negative sine or negative cosine. The cosine will start at the negative amplitude, and for the sine function, we'll want to go directly to the negative amplitude afterwards, after we start at the midline. Okay. Is there any questions I can answer with this one? Okay. So let's take a 5-minute break here, or about 6-minute break, and then we'll come back for the inverse functions. We have another section of inverse functions to look at. So we'll come back at 9:10, and we'll take a look at section 4.6 together.
Professor.
Yeah.
I gotta go pick up my brother real quick. Do you mind if I just real quick? It'll be like 15 minutes.
That's fine. Yep. Whenever you can get back is great.
Awesome. I'll stay like.
Could you just slide the screen over just a little so I could see the side? Okay, thank you.
Did you still have a question, Joseph? All right, we will get started again with this next section. We're going to be doing a little bit more work with our inverse functions for chapter 4.6. If you guys are ready back with us, go ahead and give us a thumbs up, and we'll get rolling on this last section of chapter 4. And we're going to kind of cut to the terms of the inverse functions that we're going to want to know about. We're familiar with the inverse function to a point here. There's a couple ways to represent our inverse function, one with the kind of sine to the -1 or cosine to the -1, or we've used the arc sine, arc cosine notation before. Both of those are the same function. They're just written in a different format. Let's just recall the nature of an inverse function. The nature of an inverse function accepts a side ratio. So a side ratio for a right triangle, and it gives back an angle. The y is some theta angle. Okay, so that's important to remember for our inverse functions. Another thing that's important for us to note is that the sine, cosine, and tangent will have solutions in specific quadrants. So for a sine function, the result of an inverse function can actually only be in two places. If we have a positive ratio, sine can only be positive or negative. If the sine has a positive ratio, then our angle is going to be in the first quadrant. So that's for a positive ratio. And if our sine is a negative ratio to start with, we'd have an angle in the fourth quadrant. So just with the nature of a sine inverse and a cosine inverse, for a sine inverse here, the only solutions to that inverse problem will be in the first quadrant or the fourth quadrant, depending if it's positive or negative. So for instance, if I had a sine inverse of, say, 1/2, this angle we could predict is going to have to be in the first quadrant because it's a positive ratio. And the only way I get a positive ratio for a sine function is if that angle resulting, if this is equal to theta, that angle is going to be in the first quadrant, or Q1. So that will be kind of that positive case. If it's a negative ratio, we know the resulting angle is going to be in the fourth quadrant. Is there any questions with that distinction? So cosine is a little bit different. The cosine function ranges from, or the cosine inverse ranges from 0 to pi. So therefore the solutions are going to be in the first and second quadrant. So for positive results or positive ratios will be in the first quadrant. For negative results will be in the second quadrant because cosine is negative in the second quadrant. And then tangent will be really similar to the sine function. So it has the same range. So we'll have positive results give an angle in the first quadrant, and then negative ratios give another solution in the fourth quadrant. So this just kind of helps us to draw our initial pictures for these inverse functions in the correct quadrant. Okay. Any questions with these inverse functions before we jump into the examples? Okay. So the first one is, I think I had before. We'll just do these singular inverse functions, and then we'll take a look at what are I like to call nested trig functions. So we want to evaluate these without a calculator, and we want our answer in radians. So the first thing I'm going to look at is the ratio, and I notice that this ratio is positive, and it's a sine function. So if it's positive in a sine function, we know the ratio is going to, or the angle that produced here, so theta is a solution here, some angle, that's going to be drawn in the first quadrant because we have a positive and a sine. So notice that even if it does have a positive ratio inside, we will get an angle in the first quadrant. So all these, if we have a positive ratio for the sides, it's always going to be an angle in that first quadrant. So we'll dive in here. We're going to want to draw a right triangle in such a way that a sine function would give us a 1/2 ratio. So let's build our quadrant. We'll have an angle called theta. We're solving for that angle theta. And we have a sine of 1/2. So in this case, we'd have 1 as our opposite, 2 as our hypotenuse. What would that make our adjacent side?
Would it be 3? Is it a 1, 2, 3 or whatever?
Yep, √3. Excellent. Yep. And based on that triangle formation, that's really a 30, 60, 90 triangle there. What's the angle theta here?
Wouldn't it be 60?
Close. Yeah, it's going to be a 30 degree because we're opposite the short side. So this would be a 30-degree angle, or if we're going for radians, that would be pi over 6. So if we want to get that radian angle, that solution would be pi over 6. All right. Any questions with that first A example? Okay. I'm going to have you guys through the next one. We have an arc cosine of negative square root 3/2. So if this is equal to some angle theta, and I want to draw a diagram for this, what quadrant should I be drawing this diagram in? Yep, that would be correct, right? Aiden and Anya, quadrant 2, because we have a negative angle or a negative ratio, and it's a cosine function. So the second quadrant is where the cosine is going to be the negative. So we'll build that ratio in the second quadrant. Really, this is my angle theta, and this is really just a reference triangle in that second quadrant. Okay, so if I have negative √3/2 and a cosine, that would mean negative √3 is the adjacent. That matches up our negative coordinate. And then we have a 2 again for the hypotenuse. This looks fairly familiar. What would be our opposite side here? Right.
1.
So that would be 1 again. Excellent. All right. So if I wanted to think about what is that little reference angle, I'll draw this different color, that reference angle in this triangle. What would that blue angle have to be? Great, Sam, I think you got it. The reference is the 30 degrees, or again, pi over 6. And then your outer angle would have to be 150, or we'd say that is 5 pi over 6 is the theta. So here our theta angle would be equal to 150 degrees, or call that 5 pi over 6.
So we're really just trying to find theta angle, and to do that, we just find the reference angle from the other triangle.
Yep, exactly. Yep, since it's in the second quadrant, we just want to first find the reference angle, and then we're subtracting that reference angle from pi in this case to find the angle that wraps around. And it's perfectly fine to kind of work these problems out in degrees, and then since you're more comfortable with degrees at this point, you can work those out in degrees and then convert your final answer to the radians, because you really only need that final answer in radians usually. So perfectly fine to work with degrees until then.
Chicago?
Yeah.
I have a question. So it's not clicking yet, but so how did you get 150, or I guess pi over 6? I mean, I know 150 is pi over 6, but how did you get 150 as a reference degree? Like, how did you do that?
So the 150 is this angle right here. It's the theta angle that wraps around. The reference angle is the pi over 6, because that's going to be a 30, 60, 90 triangle.
And it's always going to be pi over 6 on the inside? I mean,
not always. It just depended on what reference triangle you have. So if I have a triangle that has 1, 2, and the root 3, that's a 30, 60, 90 triangle with the sided opposite the 1 is always the shortest side. So that would, or the shortest angle. So that would be 30 degrees or pi over 6.
Can we use third quadrant?
Question on the quadrant?
My question is, can we use third quadrant?
So you will never use the third quadrant for the inverse functions.
Okay.
Yeah. So you're only going to be using the first, the second, and the fourth quadrant if we're working with inverse functions. All right, let's take a look at one more of these singular inverse functions with the tangent. So tangent is equal to -1, or tangent inverse of -1. Since this is negative, we're looking for a quadrant other than 1, right? So I think, Anya, you had quadrant 4 here. I think that would be correct. That's where their tangent function is going to be negative. So since this is negative tangent, that means we're going to be in quadrant 4 for this sketch. So if we work with quadrant 4 and we want a tangent of -1, well, we can consider tangent as -1 over 1. So the opposite adjacent is going to be -1 and 1. So we could write it like this. We've got the opposite side, -1. Adjacent side is going to be just +1. Notice since these two are really the same absolute value on the legs of our triangle, these two angles have to be equal as well. Yep, that would be a 45-degree angle right here as our reference. So we do have a 45, 45, 90 in that fourth quadrant. This would be square root of 2. Yep. All right, and what would be our full angle that would wrap around to that fourth quadrant? What's the angle that we're for here in terms of theta? When we can consider this as it's 45 degrees less than 360, so we did 360 in this case minus 45. We could get that angle of 315. Anya, I think you've got it in the chat as well. So 315. Or if you considered the radian calculations, this would be pi over 4 for the reference. So you could say this is also 7 pi over 4, the radian solution. So Aiden, you got that, nice work. All right, so that would be our solution for this singular inverse function. One other thing I want to note here is that we only get one solution. One solution. If you remember that just the regular sine and the cosine functions got two solutions when we were doing their regular evaluation, but the inverse functions have to only get one solution because they're going to be one-to-one functions that have an inverse. So they get one solution for each input. All right, so that is a little review. I think we've done maybe a little bit, but not a ton. Is there any questions with these singular inverse functions here? One input, one output. Okay, so let's continue. I'd like to maybe save some time for some explanation for the midterm. So we're going to walk what we'll call these nested functions. And these look more complicated than they are. So I want to walk through these with a picture again and just show how we can walk through these with minimal complications, hopefully. So we want to evaluate each inverse function in radians without a calculator. So there's really two trig functions involved in this problem. There's a tangent inverse, and then there's a cosine on the outside. So what I'm going to be concerned with is working this problem from inside out. So I'm going to first think about the inner function. That's 10. And then I'm going to evaluate the cosine after the fact. So one thing we know from our last problem, or last section of problems, is this tangent inverse is going to give me back an angle. So this is going to give me an angle as a result. So I can actually rewrite this as cosine of theta. And I'll just replace that whole tangent inverse by theta. Because again, tangent inverse of 3 over 4 is some angle. I don't know that angle, but I know it is going to be an angle measure. So if I call that theta, then I'm going to just draw a picture to represent that angle as theta. So let's draw a picture. And again, I'm going to just be thinking about that tangent inverse that I highlighted. I'm just focused on that. And I'm going to draw a picture here to represent tangent inverse of 3/4. So if I was going to draw this, what quadrant should I be in? Right? It's a positive ratio. Tangent inverse 3/4 is positive, so we're going to be in the first quadrant, right? So if I was going to have some angle, we'll call theta here, I know that the tangent is the opposite, we'll call 3, and the adjacent, we'll call 4. That's exactly what tangent inverse of 3/4 would look like if we had an angle theta. Now, if I considered the hypotenuse side, what would that hypotenuse have to be for this specific
5.
triangle? This would have to be 5, right? It's a 3, 4, 5 triangle. The Pythagorean triple. Okay, now, since I've drawn everything for that tangent, I now have just theta to work with. And I can now bounce to my outer function. So now I'm going to consider cosine of theta. What would the cosine of theta be just based on the picture?
Four over 5.
5/6 again?
Yeah, it would be just, yeah, so we don't need to know the theta angle. I just know its relationship between its sides. And in this case, in relation to its sides, adjacent and hypotenuse would be in play. So that would be just 4/5. That's exactly right. 4/5. And that would be our final solution there. So we don't actually need to know the value of the angle to solve these problems. We just have to draw an appropriate picture to represent the side ratios for that angle. Is there any questions I can answer for question A? Okay, we'll start with question B, and then we'll maybe jump to a live problem for you guys to try on your own. So we have a sine and then cosine inverse of 1 over the square root of 5. So again, since this is positive, we know that we're going to be in the first quadrant one more time. So again, I'm going to highlight the inner function, and I'm going to draw a picture and try to relate that to some angle theta. So I have this really equal to sine of, we'll call some angle theta, and we'll try to replicate theta with the information from the inverse function. So if I draw a triangle in my quadrant here, actually we should have a pretty steep triangle, something like this. We'll have our cosine, so that's adjacent, 1, and the hypotenuse is root 5, and that's going to be my angle theta. Since we are working with a sine function, I will need to figure out that opposite side for the finale here. So let's take a moment to solve for that opposite side. We'll call it maybe B. So we have square root of 5. Yeah.
Would it be 3, Mr. Oakland?
Yeah, I think it'll, let's see, is it going to be 3, 5?
Yeah, because you wouldn't do anything to the 5, would just be cancel the rad.
Yep, so we'd have, just 5 squared, 1 squared plus b squared. We'll have 5, 1, and then plus b squared. So it looks like 4 is equal to b squared, so that would make that a 2. Since we are in the positive quadrant here, b is equal to 2.
Oh, sorry.
Yeah, that's all right. It's all right to take a minute to work it out. Okay, so now if I wanted to do this finale, I think I'm ready to represent my sine of theta. What would be my sine of theta that would result here?
Two square root 5 over 5.
Yeah, we could write it rationalized. Yeah, so it would be 2 over the root 5, or that's equivalent to root 5 over 5. Do you want to write that rationalized? Yep. Excellent job. And there would be our solution. Is there any other questions on part B here? Okay, let's see. We'll go for a live problem here. If you guys want to jump into question number 3 on the live problem, open that up for you guys. And take a minute to do that.
I just got back. Do I?
Yeah. We're just going to be in the live assignment. So if you wanted to jump into that, or you can jot down the one that's on the screen here. This is in section 4.6.
Okay. Is the live assignment graded?
It's not for points, no.
Oh, perfect.
It's just for practice. Give you guys another couple minutes to work this one out.
Mr. Coughlin, I got 3/4, but I'm not sure if it's right at all.
Okay.
We'll work through it once everybody just gets a chance to answer.
Okay.
Or at least I see a few more answers flowing in.
Professor?
Yeah.
So I was wondering, instead of after class to talk to you, can I schedule a meeting today, maybe at like 12?
I won't be able to meet at 12 today. So we'll have to either during my regular office hours, or we'll have to figure out another time. But I do have commitments later this afternoon during that time.
Okay, never mind. We'll stick to after class then.
Okay.
And Mr. Coughlin, it's not letting me write the answer in the live assignment. It's like glitching out again.
Okay. You can try to close out of it and hop back in. It looks like it's working
I
for
had to refresh.
Yeah, just refresh it. So let's dive into this one. I think we've got a pretty hefty collection of solutions here. Which quadrant should we be drawing this angle in if we're considering the sine inverse to start?
Quadrant 1.
Quadrant 1. Okay. So this guy, if we call this tangent of theta, we want to represent that theta angle as the sine inverse. So first quadrant, we'll have our triangle, opposite over hypotenuse. And then looks like we have another 3, 4, 5 triangle that works out well by theta. And I think we said that at least one got 3/4. Looks like 3/4 is the common answer here. So the tangent of theta here would be in fact 3 opposite. 4 is the adjacent. 4 so just the fraction itself, tangent's not going to be part of the answer, just 3/4, just the ratio. That looks great. Comments or questions on these types of problems here?
Well, huh. Oh, okay. I see. It was just, it didn't accept my tangent 3/4. And it's like, why did I just need to put 3/4?
Yep, just 3/4, yeah.
Oops. It did not like
No
that
problem.
I put tangent.
That's all right. This is where we find out. So let me do this one real quick.
On the midterm,
Yeah.
if we like let's say we got the answer right, but we but like it didn't like what we put on there. Like if we put tangent on there, would that still count off?
Well, the answer is not tangent. So like, what do you mean by? So if you said like tangent of 3/4,
yeah,
instead of 3/4, well, that's not the same solution.
Oh,
Yeah, so that's an entirely different result. I mean, I'd give you partial credit because I saw where you were going, but it wouldn't be full credit because those are two different things.
Gotcha.
Okay.
So the ratio, the 3/4 ratio is the only solution, or I guess you could convert it to a decimal, but you know, the number
What
is
if we
what
just
we're
wrote in
looking
a
for.
decimal? Would that still count off?
No, it shouldn't count off. I mean, 3/4 is like what you should get if you're just working it the way on paper that you should. So there's no reason to necessarily put it as a decimal, but I don't think it's going to count you off if you convert it.
But let's say if it did, would you like personally count it off?
Why would you want to convert it to a decimal like that?
No, like if it was a mistake.
I wouldn't necessarily count it wrong if it was the right decimal. No. It still has to be the right solution though.
Gotcha.
All right. So let me kind of blaze through just a couple more here. Do you want to talk a little bit about the midterm and a couple ways, or at least the email that you might have seen with the invite? So one thing that for a cotangent and a tangent combo, notice that these are going to be reciprocals of one another. So we can think about drawing a tangent of 1/3. Again, it's going to be in the first quadrant. That would be 1/3 for that theta angle. And so if I'm going to take a cotangent of that same angle, we know that that's just the reciprocal of the tangent ratio. So in this case, we don't actually have to find the hypotenuse here. We already know that it's going to be our adjacent over the opposite. So in this case, this would be just 3/1 or just 3. It would be the reciprocal of our original ratio. A couple others that you might see would be the same function, cosine of cosine inverse of 1/2. Well, if you get this cosine of cosine inverse of 1/2, well, this would just be 1/2 because we're taking the really the inverse of the cosine. So we just get back to that same ratio that we started with if we have a nested cosine of cosine inverse. And then the last thing left would be, that would be it. Yeah. So just a variable x or a ratio 1/2 will be the same thing. So those are some special cases that you can remember there. It's pretty intuitive, so not a lot of trickery there. Is there any questions from this section that anyone would like to ask before I go into some midterm details?
Not yet.
Okay. All right, so this is also the all the information you'll need for the Chapter 2 exam. So if you'd like to do that Chapter 2 exam before the midterm, you guys are welcome to do that before now and Thursday if you wanted to, or you can just wait till Friday. We do need to do the midterm on Thursday because that'll be our proctored exam. So let me do this.
And midterm is based on 1 and 4, right? Chapters 1 and 4?
Yep. So the midterm is chapters 1 through 4. So everything we've covered up until today.